Hi there, my name is Krista Williams, and I am here with Adam Staruella to talk to you about Canadian Discovery, CDL1, and some of the offerings we have in the clean technology space. So I'm going to start off with an overview. We're going to talk about who is CDL, what it is that we do, and our technical competencies. And it's really our understanding in aquifers, fluid flow, hydrodynamic systems, pressures, temperatures, and water chemistry, and the interplay of all of that within the subsurface. How does that relate with the formations, the rock characteristics, the rock mechanics, and how that really applies to some of these cleaner technology offerings? Things in the mineral space, understanding the controlling mechanisms around lithium concentration, in terms of geothermal, what are formations that have a higher deliverability of fluid, where are areas that we can target because of higher temperatures, and then we're going to start to dig into what CCUS is, where we store it, and how it works. And then we'll touch and we'll circle back and we'll talk about why CDL, and what are some of the projects that we are currently working on in this space, and how we're uniquely positioned with the expertise within the subsurface to be leading the work in this space. Who is CDL? At its core, it's a hydrogeological consulting firm with a foundation of over 35 years of delivering top-notch subsurface data and analytics from basin to reservoir scale. There's a proven history in creating data sets and applications, things like the well-known well completion and frac database. We have hundreds of clients worldwide that rely on our technical expertise, whether it's with the CDL Digest to stay informed with the industry-leading E&P activities that's designed to provide insight into the geological and engineering drive behind some of the hottest plays, operators, and technology in the industry, or the knowledge base in over 300 plus technical studies and atlases that CDL has developed throughout the years. That's really been driven by our expertise in database development and the foundation in geological consulting.
So this year we're really excited to present CDL1. In the past we've offered a number of individually sold and marketed subscription products. We have the Fluid Dynamics database, which is a Montney-focused data set that encompasses pressure, temperature, landing zone assignments, oil chemistry, and water chemistry in the Montney. We have the Canadian Discovery Digest, which most of the industry is familiar with. We have play metrics brought to you by Sproul, where we have EURs and type curves for almost every horizontal well in the Western Canadian Sedimentary Basin. And then we have our technical studies library, which includes over 350 technical studies in the Williston Basin, Western Canadian Sedimentary Basin, and abroad. This year, we're offering them all as one product. It's one subscription available to your entire company. Everything's available online, and it's all at your fingertips going forward. We're really excited about this, and we hope you guys are as well. Please contact Krista and I if this is something you would like to learn more about. So who is Canadian Discovery, and what are our major technical competencies, and how do they fit into the new clean technology space? We've brought the industry a number of basin scale atlases that include the hydrogeology of the Williston Basin, of the Western Canadian Sedimentary Basin. We've brought the frac database, we have the hydrocarbon chemistry database, and a stress analysis of Central Alberta. So really, producing basin scale atlases are one of the bread and butter offerings of the company. We're extremely fit and proficient at looking at scale or basin scale pressure and fluid analysis, geothermics, which is temperature, reservoir characterization, which can mean many different things. This is, unconventional reservoir characterization, where we may be looking at source rock maturity, all the way to, aquifer or carbon sequestration reservoir characterization, where we're interested in understanding, porosity distribution in different types of rocks. We're also extremely experienced in seal analysis. So seals can mean, different things. Are we talking about sealing aquifer units, or are we talking about seals with regards to fracturing? So we have the ability to undertake analysis in both of those. And finally, geomechanics and geochemistry. These become important from many different aspects, whether we're dealing with unconventional rocks where we're fracturing or we need to find rocks of a certain thermal maturity for it to be economic, or understanding when we're looking at injection and fluid distribution in the subsurface. If we're injecting CO2 into an aquifer, what are those pressure relationships and what are we doing to the rock? Are we causing failure? And how are we changing, or how do we understand fluid flow in the subsurface as we start mixing fluids? So these are our major technical competencies.
So building further on that technical competency piece that Adam just described, one area that CDL has an extensive amount of knowledge is aquifers, and we really know aquifers. And this is driven primarily by our understanding of the hydrodynamic system. And one thing that you're going to note that's shown in this slide here is that there are a number of basins that are illustrating the pressures and fluid flow. Now, the ideal situation would be what you see here in the top left-hand corner, where you would have recharge in an area like the foothills for the Western Canadian Sedimentary Basin, and that is going to be discharged out to the east. So you've got fluids that are going from higher pressure to lower pressure. But as you will note in the schematic directly below it, the one that is more rainbow and in the bottom left-hand corner, is that this is not the case, and variations can be seen by bounding formations with different rock properties and by different structural features that can start to really define separate pressure compartments with no fluid transfer between them. So it's a complex play of basin geometry and its relationship to the hydrostatic gradient. Now, CDL has not only done this work here in the WCSB, but also in the Oriente Basin, which follows a more traditional methodology, and you can see that illustrated on the slide in the top right-hand corner. And essentially everything here, more or less, with some localized areas, line up on the hydrostatic gradient, suggesting some connectivity. And that's essentially going from that C to C prime in that area. And this is similar to what we see in the Williston Basin as well, where the main conductive units and aquifers are Mississippian. And as you can note right in the middle there are some localized areas of higher pressure, but it's more or less following that same higher pressure to lower pressure. And it's really this understanding of multiple basins, the varying geometries, the rock properties, and putting that all together that really carries forward that knowledge base in the subsurface and positions CDL very well to push forward in a number of different projects within this space. Building on that further, we have an example of some hydrodynamic mapping that was done from some previous work here at CDL within the Pekisko-Shunda. What you're going to notice on the map to your left is that it's showing the distribution of water to the gas pool within this formation. You'll see circles on this map. These are highlighting the areas where DSTs were taken, analyzed, and interpreted in relationship to this system. And as many are aware, you can have some pretty complicated geology in carbonate rocks and different facies that have happened. And what those facies do is they really drive the connectivity in the pore space. And it's understanding the fluid interactions in relationship to the hydrostatic system that helps us break out where these pools are. And that's what you see on the plot to the right, which is a pressure elevation plot. And this really helps us start to define and develop the pool boundaries that exist, because we can take those pressures in relationship to the main hydrostatic gradient to define those boundaries. And it's that knowledge and understanding of the interplay of the fluids in relationship to the gas, the relationships they have with each other, and with the rocks that they exist.
So one of the things that becomes really important as we start, looking at unconventional rocks, or we start looking at, geothermal or even carbon sequestration, is understanding temperature in the subsurface. And a lot of our history has, in the Western Canadian Sedimentary Basin especially, has been, focused on developing a strong understanding of the regional and local temperature perturbances in the basin. So here, we have examples of, a geothermal gradient, and this is, a Permian and younger geothermal gradient from the Western Canadian Sedimentary Basin, where, we've created the maps to understand, those regional differences and how temperature is evolving. But it's also really important to have an understanding of how it relates structurally in depth. So the two maps on the right are top Montney and base Montney isotherm maps, which we can think of as, the temperature actually within the horizon. And, the gradient is important to understand, but it's also important to understand how that gradient relates to the depth of the rocks that we're interested in investigating. This is critical when we start looking, whether it's critical minerals, carbon sequestration, or geothermal. It's what the gradient is only part of the answer, but we also need to have a good understanding of the thickness of the rock units, the pore volume of the rock units, and how that temperature relates to the problems that we're trying to address. This is an example of, formation water chemistry expertise, and this actually came out of a spearfish study in Montana. And though it may be hard to read what's going on, what we're looking at is salinity across, southwestern Manitoba, where we have high salinity to the southwest and decreasing towards the northeast, which is, what we expect due to freshwater recharge from the Manitoba escarpment. But our expertise is really in going through the water chemistry and understanding what's going on. How do you look at a stiff diagram and interpret, are you seeing true formation brines? Are you seeing water coming from other sources in a wellbore through contamination? Are we seeing contamination from drilling bud? And how can we make a holistic interpretation of the formation waters in the surface? This is really important when we start looking at carbon sequestration and lithium, especially. Understanding the distribution of brines, brine density, and changes in the chemistry of fluids becomes critical for determining if these types of projects are going to be successful. We have 35 years of doing this type of work, and it really is a core offering of what Canadian Discovery offers.
Now we're going to move into what CDL has been doing in a number of these cleaner technology offerings, and we're going to start with critical minerals. So what are critical minerals, and why are they important? Just recently this year, in March 2021, the Canadian government came out with a list of 31 minerals that were considered vital to sustain the economic success in Canada. So they're critical because we need them in various products that we use every day. And where we have to be strategic is how we're supplying that and where we're getting it from. And are there ways that we can support the local supply chain here in Canada for these critical mineral resources? So enter lithium. Why is lithium important? And why is that something that we're starting to look at more so here than ever before? Now, lithium is very important in a number of different uses: ceramics, glass, lubricating greases, metallurgy, polymers. One of the main things that it's really important for are lithium-ion batteries. And it's that component that is starting to become in very, very high demand. And so if we can start to support our local supply chain in terms of that extraction process, then it can help sustain Canada as we move forward in the future, as well as helping to decarbonize some of the infrastructure in the coming decades. So what do we know about lithium concentrations in Western Canada? Within the last 5 years, there's been an interesting development in terms of understanding lithium and the extraction technologies from existing oil and gas fields in subsurface brines. So what you can see on the map here are a whole number of sample points and concentration values for lithium from a number of wells that have been sampled throughout primarily Alberta, but you can see there's a handful there in northeastern BC and a few in Saskatchewan. And this has really been driving a lot of the major land acquisitions for non-metallic rights. And that's what's shown in pink on the map. There are a number of players that are starting to get into this. A few to mention would be Lithium Bank, E3 Metals, Prairie Lithium, and there's many more, but are starting to develop the extraction technology so that this resource can really be viable, and we can start to look at making an impact on the local supply chain. And through a number of the sampling programs to date that have been done regarding lithium concentration, it's really kind of leaned heavily on CDL's background and expertise in water chemistry and the development of the hydrogeological atlas and the geofluids database. And when you can take all of that together and start to draw some relationships and understanding to the geological features, the controlling mechanisms, and look at areas that you can start to predict where you want to pursue over another, you really start to add value to the resource exploration and exploitation as you move further into the future. What is it that CDL brings to the table in terms of subsurface brine expertise? It's really understanding and defining the geological criteria around some of the concentration mechanisms with lithium. And it's looking at the relationship between lithium and other attributes, proxies, to help direct future efforts regarding the trends. Brine characterization using notable minor ion concentrations can also be utilized as exploration proxies with enough data, reservoir, and local geology understanding. And creating a large-scale data set with more robust information can really help define and direct where companies may want to look and what that resource potential really is. And from there, you can start to develop maps, incorporate it into a larger geological framework, and start to really build that foundation for future resource evaluations.
So one of our current product offerings is in relation to geothermal, and through this type of subsurface analysis process, we use our experience in aquifer delineation, determining fluid deliverability, hydraulic head, all those types of items, combined with our expertise in mapping temperature in the subsurface. Most technologies in the geothermal space require having high bottom hole temperatures and high fluid deliverability. What does the geothermal space look like in Canada currently? There's four major products right now, projects that are the industry's looking at. There's the Clark Lake geothermal project in BC. There's the Deep Energy project near Estevan, but most of these are focused on harvesting high heat water from wells with very high deliverability. So we're typically looking at deep reservoirs, high bottom hole temperatures, high porosity, very high permeability. And through our experience in mapping aquifers all over the basin, understanding the hydrogeology of the subsurface and our atlas level understanding, we can help you determine where the best reservoir units are and which areas have the highest potential to have an economic geothermal project. The projects themselves, there's a number of different technologies. There's open loop, there's closed loop. We can be involved anywhere from the pilot scale, which are quite small, all the way to multiple 100-megawatt field development projects. One of the challenges with these, though, is understanding the relationship of the subsurface and where high deliverability aquifers are and related to transmission and distribution networks. So we can definitely help you with that. The big ones, though, when we start looking at the optimized heat flow, temperature, and deliverability, most of these we're going to be looking at Devonian reefs, and we're going to be looking at basal Cambrian sands, which we have a multitude or an extensive experience in analyzing these types of reservoirs.
So now we're going to move into carbon capture and utilization and what CCUS is. CCUS is carbon capture, utilization, and storage. Essentially capturing carbon dioxide before it enters the atmosphere. This can be done by purifying it, removing some other components, and then compressing it, transforming it into a liquid. And this is done dependent upon the type of process that is being utilized. And that can be shown here on the schematic, where you look at the capture from the facility here, and then you start to transport it down, and then you get it to the injection, where you are going to inject it into the subsurface. So this is part of the utilization and the storage. So the utilization piece is where you're going to take that CO2 that has been injected, and that's going to move over and enhance the recovery of oil from an existing producing reservoir. So the CO2 is injected into the reservoir. Stripping more oil then could be recovered in traditional methods, and then it gets pumped back up to the wellhead here. When it comes to the storage piece, when it's compressed into a liquid, we have the opportunity to inject it deep into these deep saline aquifers for extended period of time in the magnitude of millions of years. The role of depth in storing CO2 is very important because it's where you're taking the volume of the CO2 at surface and you're compressing it past that point of the critical depth, which is shown in the schematic at 800 meters, into a supercritical fluid. So the supercritical conditions for CO2 comprise a temperature in excess of 31 degrees C and a pressure greater than 72.9 atmospheres. So CO2 is like a liquid, but it has a viscosity like a gas. And the main advantage of storing your CO2 in supercritical conditions is that the required storage volume is substantially less than if the CO2 were at standard surface conditions. Elaborating further on CO2 storage within the subsurface, there are a number of key criteria that need to be considered in determining your site identification. You need to look at your reservoir CO pairs, your pressure regime, the monitoring potential that you can have within the area, where existing groundwater is, and what some of the quality protection and controls are within that and how close you are. And there are a number of storage types. So the first type, which is shown here on the schematic, is storage within a saline aquifers. This has the highest capacity for long-term storage and large volumes of storage. Then the second type is storage within existing depleted oil and gas reservoirs. These are inherently suited to store CO2 for long periods of geological timescales, and we have an extensive knowledge base and understanding of what's going on in those parameters. By understanding existing well logs, seismic, and production data that really help us do the proper reservoir characterization. And initially, when we were exploring to look for oil and gas from these formations, we had to take all of these considerations in place. So the parameters that are around these pools and these reservoirs are very well known. And then the third type would be enhanced oil recovery, which I touched briefly on in the first schematic, but this just really maximizes the existing resource recovery while minimizing the environmental impact. A number of pools would not be able to produce further under traditional methodologies if enhanced oil recovery wasn't put in place, and CO2 can really maximize that recovery. And where CDL is strategically positioned is understanding the geological models and the flow simulation and what the parameters need to be around in terms of the test injectivity and capacity before huge capital investments are made.
So we're really excited here at Canadian Discovery to be a part of CCUS. One of the exciting things for us is our experience in aquifer reservoir characterization and delineation is crucial to understanding where and how to create a successful carbon sequestration project. We can definitely say going forward in Alberta and the Western Canadian Sedimentary Basin that we're in an exceptional spot for building and developing these types of technologies. We have many industries that emit material amounts of CO2, and we can definitely find a good home for it if the economics and legislation determines or makes it a cost-effective solution to dealing with CO2. It's important to discuss, what it takes to get a CCUS project off the ground. And this is really, this slide here is just outlining what an application can look like. This is just, assessing, do you have the ability to store it? How can you get that first pass assessment into the government? Many steps come after this in determining, broader scale project economics, what type of carbon sequestration technology might you use, how to continually develop and alter a monitoring and verification and measurement plan. But it's just important to understand that at the start we need to focus on understanding what the application requirements are, and they're different. Here in Alberta, the requirements are different than they are in BC. They're different than in Saskatchewan, and these things are continuously evolving. What we're very good at is evaluating what the storage options are. This will be dependent upon where one is located, the volumes of CO2 that one's going to be looking at injecting, understanding risk, so understanding and determining how you can find redundancy in storage options, and figure out how to develop a submission plan, so what's actually required. Next steps that should happen pretty early are, we need to make sure we're doing a good job consulting with mineral owners, communities. So these include cities and towns, these include First Nations, they include essentially everyone. We as an industry need to make sure that we are doing a good job of outlining how we're going to safely do this, how we can answer the challenges from communities and people that are interested, and how we can encourage them to be a part of this solution. The next step, really is to develop a monitoring, measurement, and verification plan. These can be quite robust. They can include things like fiber, seismic, walkaway VSPs. There's a number of different technologies, and it's going to depend on the scope of the project and the location as to what these types of technologies are going to be needed for measurement and monitoring. After that, you'll submit an application, and you're going to wait to hear back from your government entity and determine what was successful in your application and what's going to require further amendment. This can be at any step in this process, from evaluation of storage options to consultation, but we need to make sure that we're doing a good job of listening and answering all the questions we can to do these projects safely. So what has Canadian Discovery been involved in? We have been involved in a number of bespoke consulting projects. So these include evaluating depleted oil and gas pools for storage. We've evaluated EOR opportunities in depleted oil pools. We've done basin scale atlases of British Columbia, and we're currently involved in doing another one in the Gulf of Mexico and the United States. We're also, really excited to be working on a 5 million ton per annum carbon sequestration storage project where, we're evaluating and determining, which of multiple potential aquifers are suitable for storage. So we've been, quite successful in that space and working with a number of projects. And our focus really going forward is going to be, on that consulting offering. We're also, in the process of marketing here in Alberta a depleted pool and EUR targets atlas of the entire province, and doing a regional aquifer and geologic storage delineation atlas. So whether one's in the Deep Basin near Edmonton or out in Medicine Hat, what are the storage options for you? And then from there you can determine which ones make the most economic sense.
Why CDL? It's the experience and our technical competency within the subsurface. I hope we've been able to illustrate today the range of knowledge that we bring to the table and how this is really applicable in some of these emerging, newer, cleaner technologies, and basically trying to understand the subsurface and the resources in a different way. And what it is that we bring to the table is that proven expertise in geological assessments and understanding the entire system, whether it has to do with the pressures that are in place, the temperatures that are in place, the water chemistry, the rock characteristics, the petrophysics, and taking all of that immense amount of information and knowledge and applying it to each one of these unique situations is really the value add that CDL brings to the table. We would like to thank everybody very much for taking the time to listen to our showcase presentation. And, just as a heads up, you can head to our virtual booth and download your free poster of the drilling activity here in 2021 and check us out at the exhibit hall. Both Adam and my contact information is here, so please let us know if you have any questions, comments, ideas. We'd be happy to chat further. Thanks, everybody. I hope you have a great convention.